Hello, good evening, students. Good evening to all of our students in India, and good morning to all of you here in the US. Welcome to Saturday's Story of Science with Omkar. So, this is the very first episode of our program. Over the next couple of months, we'll explore the science of stories, science stories with Dr. Omkar Deshpande. Omkar is currently living in the San Francisco Bay Area. Uh, he has a computer science degree from IIT Delhi, and where he was a gold medalist in his batch and a top IIT ranker, maybe in top 20. Uh, he has a master's and PhD in computer science from Stanford University. After working various software companies, Omkar now helps people how to code, how to become a good software engineer in top-notch companies in the world. In his spare time, he tells science stories to students like you. I have known Omkar for almost 10 years and worked with him on various different projects. And he's also our founding advisor at Aveti Learning and also our chief storyteller. So we are looking forward for this series of episodes that's going to happen from now, and this will be done in English. As you know, a lot of you are attending this guest lecture with Aveti on Sunday at 9 p.m. But it's Saturday is a brand new program, and in this program we are going to based on a particular theme and with a expert, internationally known expert in that area. So, without any further delay, I would like to welcome Omkar. Hey, Omkar, are you there? You can.
Yeah. Should I share my screen now?
Yes, please. Just a minute, something gone wrong. Internationally known expert in that area. So, without any further delay, I would like to welcome Omkar. Hey, Omkar, are you there? We can.
Yeah. Should I share my screen now?
Yes.
Let me know when I can start.
Yeah, yeah. Okay, Omkar, you can yeah, share the screen. So I think you can see. Uh, go ahead.
Okay. Thank you for the introduction, Vishwajit. A very warm welcome to all of you. In this series, we are going to go on a journey together. We're going to travel back in time to the ancient world to understand how our predecessors, how our ancestors invented science. I'm sure that you have both history and science as subjects at school, but this is going to be different. We are going to be looking at the history of science. How and why did ancient people invent science? We are going to follow their trail carefully and understand how they solved various mysteries in their quest to understand the universe. We will not only have fun solving many important mysteries, but we will also gradually learn to change the way we think. Learning science is difficult because science goes against our default common sense. Common sense tells me that the ground on which I'm sitting is at rest. But science tells me that the earth is not only rotating but rushing at an enormous speed around the sun, 30,000 meters per second. That's the estimated speed. Can you believe that? I don't feel myself moving at all. When I'm sitting in a car or a train, I can tell that I'm moving. Or even if I'm taking off in an aeroplane, I can tell that I'm moving. Because if I open the car window or the train window, of course, I can't open the plane window, but if I could, I could feel the wind blasting my face, but I don't feel any motion of the Earth, nor do I feel a massive wind. And scientists are telling me that the Earth is traveling at a speed of 30,000 meters per second. Why should I believe that the Earth moves at all? Why should I give up my common sense? If you don't find science going against your common sense, there is something wrong in the way you are learning it. That is why learning science is such a transforming experience because it tears us apart from our common sense and changes the way we look at the world. The earliest science that was invented was astronomy. And so our focus in this series is going to be on the story of ancient astronomy. And we will begin our journey all the way back in prehistoric times, before any of the civilizations were born. That is what we will start doing next time onwards in our second session. In this first introductory session today, I'm going to begin in the present and give you a taste of the type and style of content that we will be covering in future sessions. So let me begin with a true story. The city of Los Angeles on the California coast is the second largest city in the United States by population, the largest being New York City. Home to Hollywood, sunny beaches, and amusement parks like Universal Studios and Disneyland, the Los Angeles area is a treat to visit, especially for kids. About 27 years ago, on January 7th, 1994, it was 4:30 a.m. in the early morning hours when most of the city was asleep. Suddenly, the sleeping residents were woken up by a nasty jolt. The ground started shaking violently. It was an earthquake of magnitude 6.7. In the darkness of the night, as the shocked people ran for cover, highways collapsed. These pictures were taken later in the daytime, but the damage happened in the night during those 10 or 20 seconds. More than 50 people were killed, and more than 8,000 were injured. Life in one of the most famous and busiest cities in the United States screeched to a halt because highways had collapsed, hospital buildings like this one were badly damaged, and many houses were destroyed. Gathering outside at 4:30 a.m. on the streets that were suddenly devoid of power, many people felt that they were safe because they were outside now. But when they looked up, they were shocked. A giant, eerie, silvery cloud that they had never seen in their life stretched across the early morning sky. Many people were afraid that this scary cloud had something to do with the earthquake because it had never appeared before. So many people, many of them, went into phone booths and started calling emergency centers to report what they were seeing. They couldn't believe what they were told, that what they were seeing here was the normal appearance of the night sky, and that the giant silvery cloud was the Milky Way. You couldn't blame the people for getting scared of the Milky Way because the night sky that they were accustomed to every night looked very different. The top image here shows what the sky looked like just after the earthquake. The bottom image shows what the Los Angeles sky looked like on every other night. including that night before the earthquake happened. So, how could the earthquake cause such a drastic difference in the same sky? What do you think? Let me give you 10 or 15 seconds to think about the answer. The answer lies in the bright lights that emanate from the major cities at night. This is Mexico City, the capital of Mexico, and the most populated city in the continent of North America. Notice how much light is directed up into the sky. All this light gets scattered by the air in all directions, and as a result, the sky above the city appears to have its own faint glow. Here is a diagram that shows more clearly what's happening. So, just like in the daytime, we cannot see the stars even though they are there because the light of the sun outshines them. What happens is at night, the sky glow from the city lights makes most of the faint stars invisible to us. You can see here that the light from the buildings in the city is going up, and then the air above the city scatters that light, and from different parts of the sky, the light reaches an observer who's standing somewhere in the city. And all that light is mixed up with the starlight that is coming from far away from these faint stars. And so you can't see those faint stars because just like the sun blocks out all the starlight during the day, the sky globe blocks out all the starlight or much of the starlight in the night. But if we go to an environment that is far away from city lights, then we can see things that we could never see while living inside or close to a city. When the earthquake happened in Los Angeles, there was a complete power blackout. The sky glow, as a result, was gone, and the night sky appeared just like it would far away from the city. If you find it hard to believe how much light goes up in the sky from a city, look at this satellite view of the world at night. You can spot dense concentrations of people because you can see their city lights even from space. For example, look at the lights along the Nile River here in Egypt. Much of Egypt is a desert country with all the major cities located along the Nile River. So by looking at the cities, you're actually looking at the Nile River itself. France is somewhere here, and this spot here is um, the capital city of Paris. So if we zoom in, this is the satellite view of Paris at night. Notice just how much light is emitted from the city into space, far beyond just illuminating the city. It is this wasted light that then blocks our view of the night sky. And there is a term for this unwanted light. It's called light pollution. It is light pollution that prevents us from observing the Milky Way and thousands of other stars in the night sky. Unfortunately, this makes people living in cities, which means most of the world's population, more and more distant from the mystery and beauty of the universe. Some cities have begun trying to reduce light pollution by changing the street lights. So instead of using lamps that emit light sideways and upwards, they've started using efficient street lights that only project light downwards. But still, if you are living in a city, chances are very high that you are cut off from the night sky. So let me ask a quiz question. The most powerful telescopes, right? Telescopes, as you know, are instruments used to observe the night sky. The most powerful telescopes are kept inside special buildings whose roofs can open whenever needed so that the telescope can look out at the sky. These buildings are called observatories. So, why do you think observatories are located in remote places? For example, this is Lick Observatory, an observatory that's located very close to where I live on Mount Hamilton near San Jose in California. So think about why observatories are located in remote places.
So if any of you have answer, you can write the answer in the chat box. I'm seeing it. And if you have any questions, you can always ask and we can interrupt during the time. And also students, you stay on and we are going to give you the Zoom link so that you can join after the guest lecture, after the story time Omkar is over. Yeah, so please type your answer and then okay, Omkar, you can keep going whenever you
Okay,
feel.
so the answer is that remote places are, by definition, far away from city lights, and so they are unaffected by light pollution. So many observatories are located on the tops of mountains far away from cities. Such locations also have an additional advantage, which is that the air up in the mountains is thinner. Since the light coming from the stars is scattered by the air, having a thinner blanket of air above you makes the light scatter much less. So you can see the stars more clearly. The blanket of air that hugs the earth is called the atmosphere. And if you want to totally avoid light pollution, there is even a telescope that has been put completely outside the atmosphere of the earth. And this is the Hubble Space Telescope, named after famous astronomer Edwin Hubble. The telescope was launched by a rocket and has been orbiting the Earth since 1990. And some of the clearest images of the universe have come from the Hubble Space Telescope. Since most of you are in India, uh, this is the Indian Astronomical Observatory located near Leh in the Ladakh region. It is the highest observatory in India, about 4,500 meters above sea level. But the highest observatory in the world is University of Tokyo's Atacama Observatory. It's located in the Atacama Desert in Chile, in South America, at a height of more than 5,600 meters above sea level. Here's another quiz question. You must have seen that the moon appears to change its shape on different days or different nights. Sometimes you see it as a full moon, at other times you see it as a crescent. So, would a sky with a full moon or a crescent moon be more suited for watching stars? Think about
So,
that. What would be a good night to go out to watch the stars when the moon is crescent shaped or when it's a full moon?
okay, so you can answer your question here. So question is full moon or crescent moon, which is good to watch stars? So if you say full moon, you can write or crescent moon. Some people are typing full moon, but I will give you some more time to answer. So the question is which crescent moon or full moon, which is good to look to watch stars in the night. So there is, I think, 50-50 answer. Some people are saying
Okay.
crescent, some people are saying full moon. Uh,
Okay. Good.
okay,
So there
guys,
should be.
very good participation. I think we have about 114 students live right now,
Mhm.
and I think they are answering like crazy. I'm not really able to get, but anyway, the I think now is turning to mostly full moon. I don't know. So you can reveal your
Okay.
answer and let's explore.
Okay. So the answer is a crescent moon, right? In fact, the perfect night is a night when there is no moon at all. Uh, the light from the moon also makes it harder to see the faint stars clearly, right? So that's the reason why a night with a crescent moon is better for stargazing, because less light is coming to us from a crescent moon than a full moon, right? Think about what happens in the daytime when the sun is out there. It's not like the stars are not there, they're still there, but the bright light from the sun blocks out all the starlight. And in a similar way, to a much smaller degree, but still to a significant degree, if you want to see the very faint stars, it's harder to do that on a full moon night. Okay, let's proceed ahead. So, people who lived before electric lights were invented were certainly more familiar with the beauty and expanse of the nighttime sky. Unlike the residents of Los Angeles, our ancestors' normal understanding of nature included the Milky Way, as do many people living in rural areas without electricity today. They would never have seen the Milky Way with fear and dread like the residents in Los Angeles. And let me give you two examples from the past. First, we have a story from ancient Greece that tells us how the ancient Greeks understood the Milky Way. In the Greek religion, there were a number of gods, but the king of the gods was Zeus. Zeus's wife was the goddess Hera. Now, though he was king of the gods, Zeus was not perfect in character. He would often chase other women, both earthly and divine. And in one such infamous episode, he conceives a baby with an earthly woman disguising himself as her husband. That baby, which is born, is the most famous Greek hero, known as Hercules by the later Romans, or Heracles in Greek. Here you have a statue of Heracles from, I think, the Roman times, uh, showing a famous episode where there are a couple of snakes that try to attack him and he strangles them to death. Since Heracles' mother was human, his father was Zeus, but his mother was human. He was also a human by birth. He was not a god, which means that he was mortal. The Greek gods were immortal. That means they had a birth, they were born, but they would not age and die like humans. So, according to the legend, Zeus took baby Hercules to Hera up in heaven while she was sleeping. He placed the baby Hercules on Hera's chest so that Hercules could drink her breast milk. And by drinking the breast milk of a goddess, Hercules would become immortal. Okay, Hera was naturally jealous of Hercules. She didn't want him to become immortal. So Zeus does this while she's sleeping. But Hercules sucked so hard that Hera woke up with a jerk. And instead of the milk going into Hercules' mouth, her breast milk sprays across the heavens. And that milk is what you see, or what the Greeks saw, as the Milky Way. So when they looked up at the night sky, they weren't scared like the residents of Los Angeles. They recognized what they saw as a heavenly spray of milk. That's the title of today's introductory session, a heavenly spray of milk. That's what the Milky Way is. And that's where the name Milky Way comes from. It comes from this story. In ancient India, on the other hand, the Milky Way was not thought of as being made of milk. Instead, it was a river. It was a river with pristine water flowing through the heavens, known as the Akash Ganga. This was the Ganga river that originally flowed in the heavens, with her source being the feet of the god Vishnu. The water was considered so pure, in fact, it's still considered so pure by Hindus, that contacting it could assure a person of attaining the highest heaven. A pious king on earth named Bhagirath wanted the Ganga river to come down to earth. He wanted it to flow over the ashes of his ancestors. There were about 60,000 of his ancestors whose souls were supposedly still trapped um, on earth, right? They had been burned to ashes and their souls were still trapped there since their death several generations ago. So Bhagirath wanted the souls of his ancestors to attain the highest heaven. And so he does severe penance. You can see him doing penance here in the Himalayas to please the goddess Ganga, who personified the Ganga river. And when she was satisfied, she agreed to flow down to earth from the heavens and fall somewhere in the high Himalayas. In fact, she requests Bhagirath to do penance to the god Shiva so that she can land on the head of the god Shiva who sits there in the Himalayas to cushion the enormous impact of the force of the water as it falls down on the earth from the heavens. So Bhagirath does a separate penance to Shiva, who agrees to let the Ganga river descend on his head. And from there, the different streams of the Ganga river flow down the Himalaya mountains across the plains of India, making them fertile until the Ganga river enters into the Bay of Bengal. So the ancient Indians were also not scared of the Milky Way because it was this divine Akash Ganga river. So these were just two examples from Greece and India. Every culture had stories that helped the people make sense of what they saw in the night sky. Right? Nobody wants the night sky to look like a mystery or something scary. And so these cultural stories comforted people and made them look at these um, entities in the night sky, the sun, the moon, the stars, planets, the Milky Way, as something very familiar. About 400 years ago, the telescope was invented. It was originally invented as a spyglass to keep an eye on enemy ships that might be approaching um, the coastal cities um, in Europe. You might have heard or read about Galileo Galilei in your science books. He was a famous astronomer and philosopher and one of the founders of modern science who lived in the region that is, modern day Italy. We'll meet him in detail later, but I want to point out one specific thing here that he did. He designed his own improved version of the spyglass, or you can say telescope, which enabled him to look at the heavens more clearly. And he pointed his telescope at the moon, the stars, the planets, the sun, and so on. But when he looked at the Milky Way through the telescope, he was surprised because he saw that it was not a continuous cloud of milk or any other fluid or gas as was thought until that time, but the Milky Way turned out to be a dense cluster of a huge number of discrete stars, millions of them. In fact, scientists estimate today that there are about 100 billion stars in the Milky Way. So, with the telescope, Galileo could see a huge number of stars that were, until that point, invisible to the naked eye. Scientists tell us today that the huge collection of stars making up the Milky Way is called a galaxy. But what is a galaxy? The word galaxy comes from a Greek word which, not surprisingly, means milky. Right? The Greek word galaxias means milky. And so it's not surprising that the Milky Way is called a galaxy. So here's a diagram showing what the Milky Way supposedly looks like. Okay, our entire solar system is just a tiny speck in the outer region here of the Milky Way. We can't see the spiral shape of the Milky Way. Notice that the Milky Way is shown as a spiral. Why can't we see the spiral shape of the Milky Way using powerful telescopes?
So anybody wants to answer? You can always type and also ask your questions here. So I'm basically looking at, and then I can ask to Omkar so that we can also answer your question. So I'm monitoring the YouTube discussion forum. So please answer your question and ask. Sorry, please answer the question right now we asked, and also your questions, please. So why can't we see everything in the Milky Way? That was a question. Okay, Omkar, I think we can go because
Yeah.
so they're trying to answer. There's some delay, but you go
Okay,
ahead.
sure. So we can't see the spiral shape of the Milky Way because we have to rise above the plane of the entire galaxy to see its shape. So, from our vantage point inside the solar system here, we can only get a side view of the galaxy, and that too just the stars that are relatively close to us and not blocked by other stars. So, what we see is the Milky Way as a band running across the sky, similar to what you see here. So this is like the side view of the Milky Way. And these other stars are stars in other directions, still part of the Milky Way, almost all of them, but more uh, located more in other regions, in other directions. Okay. So we have seen how humans look at the Milky Way in a way that gives their cultural life in the universe more meaning. But it's fascinating to know that even some animals look at the Milky Ways in ways that practically benefits them. So let me tell you one final story. This will be gross, maybe a little funny, but certainly gross. I don't know if you recognize this creature.
So which
It's
creature is this? Can anybody tell? What you are seeing right now on the on your screen? This is an elephant, or this is a tiger, or this is a snake, or this is what is this? I think some people are saying some sort of ant or something.
Yeah, so it's a dung beetle, right? So uh, it's called a dung beetle. It's found in every continent, including in India, Asia, Africa, and the Americas, except Antarctica. And as its name indicates, the dung beetle loves dung. It loves poop, right? Feces. They feed on poop and they lay their eggs in poop. And when those eggs hatch, their babies start eating all that poop. So it turns out that poop or feces have some nutrients, and for the dung beetle, all the nutrients that these beetles need. The only problem is that once they discover a food source, there is stiff competition from other beetles. And so things get crowded very quickly. So, in an effort to secure enough food for itself, the dung beetle tries to make a, a ball of dung. It tries to roll the dung into a ball that is larger than its own body and quickly roll it away with its hind legs before any of the other beetles can snatch it. So here you can see there's a lot of competition. So some of these beetles are going to roll the dung into a ball and try to roll the ball away before other beetles uh, snatch it. So here you can see that there are a couple of dung beetles that are fighting over this ball of food. Now, to avoid a face-off, to avoid running into other beetles, the dung beetle needs to roll the dung ball away from the crowd in as straight a line as possible, right? And as quickly as possible, because if it doesn't follow a straight line, it's possible that it might roll the ball back into that crowd, and the ball can get stolen by a more powerful beetle. So how does a dung beetle know what direction to maintain when making its way away from the dung heap? It turns out that during the daytime, the dung beetle looks up at the sky and uses the location of the sun as a reference point in order to maintain a fixed direction. So let's say I'm a beetle and I see the sun exactly on my left when I start rolling the ball away. I will make sure that even though I'm upside, almost upside down like this, these are my front legs and these are my back legs. So as I'm pushing the ball away, I'll try to make sure that the sun stays on my left. Right? If I start seeing it in a different direction, that means I'm changing my direction. So keeping the sun in a fixed location relative to my face, I'll push the ball and that will ensure that I move along a straight line. Now, dung beetles don't only feed in the daytime, they also feed at night. So, how do they navigate when it's dark? Well, not surprisingly, you can guess that they would look at the moon. Now, the moon is a useful reference point at night But what if there is no moon in the night sky? Then what would they do? Well, believe it or not, in South Africa, a group of scientists conducted experiments to answer this question. So they took dung beetles and they put them in an artificial planetarium. I assume you know what a planetarium is. Right? A planetarium is a dome shaped theater that is used for presenting shows about the night sky. So many observatories have planetariums also to educate the public about the night sky. So a planetarium has dark walls, and so these scientists they put these dung beetles into a planetarium with blackened walls. It was an artificial planetarium, and in total darkness inside it, they checked what the beetles do. How do they roll these dung balls away? And it turns out that the beetles found it very difficult to maintain a straight line path because they couldn't see anything. Then the scientists added points of light in the planetarium to represent the stars. The dung beetles still found it difficult to maintain a straight line, which showed that they were unable to see these stars properly. They were too faint for the beetles' eyes to see. Taking it a step further, the researchers then projected the Milky Way on the planetarium walls. And to their amazement, the beetles successfully used the light of the Milky Way to maintain a straight line path in a fixed direction. So, during times when the Milky Way was not projected high up in the night sky, the beetles were observed to be confused when navigating. But when it was high up, so that it was visible to the beetles' eyes, the beetles were able to maintain a straight line path. So the scientists who did did this research won a prize that is known as the Ignoble Prize. Ignoble. I don't know if you've heard of this English word. The Nobel Prize, I'm sure everyone knows about, named after Alfred Nobel. It is the highest honor that you can get as a scientist. The word ignoble is a play on the word Nobel, right? Nobel, even though it's pronounced the same as noble, means something different. Nobel was a proper noun, it was the name of a person, Alfred Nobel. The English word noble, as you know, stands for someone who is, part of the elite, a nobleman, and supposedly of good character. Ignoble means, you know, infamous, right? Doing something that is uh, going to make people think not so good things about you. So the Ig Nobel Prize is given to research that initially makes people laugh, but then it also makes them think. Right? So the scientists who did this research got the Ig Nobel Prize in astronomy and biology, two different fields together. So one small quiz again. The researchers who studied dung beetles, one of the experiments that they did was they also put a small cardboard hat on top of the beetles' heads to block their view of the sky. Right? So even if the Milky Way is there high up or the moon is there high up, if you put a small cardboard hat on top of the beetles' heads, do you think the beetles would be able to roll their balls in a straight line?
Yeah, so you can type your answer. So if I put a hat on top of the beetle's head, so that means I am blocking his view, but still the Milky Way is there, right? So is it going to take him in a straight line or in a zigzag line, or they'll confused? So just type your answer, straight line or not straight line. Uh, I think some people are unknown. They're saying that they do not.
Yeah, that's good. I
Uh,
mean, in reality, if you had the funding and the money to do this kind of research, you would do the experiment and see for yourself. So,
mhm.
what the scientists saw is that the beetles did find it difficult to maintain a straight line path. And these are different experiments that just confirm that what the beetles are really using to guide themselves is uh, the view of the night sky. So, if you block their eyes, uh, they can't maintain a straight line path. Now, not everyone considers the dung beetle to be a lowly creature, right? When you first hear about it, you think of it as like a very dirty creature. But it turns out that dung beetles do a lot of useful work. Imagine the amount of poop, the amount of feces that would lie out in the countryside from all the different animals and livestock and all, if these beetles did not recycle those nutrients, right, in the ecological cycle. So, uh, in fact, there are countries that import dung beetles just so that they can uh, use them in places where there is a there are a huge number of cows or a huge amount of livestock. So not everyone considered the dung beetle to be a lowly creature even in the past. So here you see a statue of a dung beetle in front of an ancient Egyptian temple complex. The ancient Egyptians were aware of the fact that dung beetles eat poop. They create a ball of poop, they roll it by pushing it with their hind legs, and the fact that they lay their eggs, sorry, the fact that baby beetles are seen to emerge out of balls of poop, right? They may not have known that these beetles have tiny eggs embedded within the balls of poop, but they certainly saw baby beetles emerging out from those balls after several days. So they still considered the beetle to be sacred in spite of all this. For example, this Egyptian god Khepri, who is pictured here, is depicted as a human being with the head of a dung beetle. Why do you think ancient Egyptians, found dung beetles to be sacred? This is a hard question, but um, any guesses?
So you can type. Why do you think that something coming out of poop is going to be a sacred? Like we can consider it as a goddess or god or whatever. You can type your answer. We can continue.
Okay. So ancient Egyptians observed, as I said, that the dung beetles are born directly out of dirt, out of poop, where several days earlier, maybe the male might have kept a dung ball, and then several days later, a bunch of beetles come out of it. So, in that sense, dung beetles symbolized resurrection. I don't know if you know what resurrection means. Resurrection is when a dead body becomes alive again, right? Starting from inanimate matter, the body comes alive again. So, the ancient Egyptians believed that after death, those special humans that were deemed to be pious by the gods had a chance of getting resurrected. That is, emerging from their burial tombs the same way dung beetles emerged from the earth. So, what they did is they mummified the dead to preserve their bodies, because if you don't preserve your body, then there is no chance that you can be resurrected. So, dung beetles symbolized resurrection for them because they seem to emerge directly out of inanimate matter. And so, what the ancient Egyptians did is they even made necklaces, which are known as amulets, where you had beetles as part of the amulets, and they were placed in the tombs of the mummies on top of these dead bodies, uh, with the idea that uh, the person had a higher chance of being resurrected if you put a necklace around the person with a small amulet of a dung beetle. So that concludes our session. Let me just summarize what we what we did today, we looked at 3 or 4 stories. And the first story we saw of the Los Angeles earthquake showed us how cut off we are from the night sky. And I told you a couple of stories from different cultures, Greece and India in particular, showing you how ancient cultures were not cut off from the night sky the way we are. And finally, dung beetles show us how even animals were not cut off. So we are going to start building that connection with the night sky, which we are missing today, from the next session onwards. And we'll see how over time our predecessors, our ancestors ended up inventing science. So we'll try to reinvent science in that way. By the way, this is a zoomed in image of the one of the amulets, right? One of those necklace beads with which is shaped as a dung beetle, kept on top of mummies in the Egyptian tombs. Okay, so that brings us to the conclusion of our first session. Thank you very much.
Okay, thanks, Omkar. And what I'm going to do, open up the thing, so you can take a quick 2 minutes break maybe. And
Okay.
we are going to start the students, bring the students online to Zoom. So all my request to students, I'm sending you the link to those who have already registered. Because I don't have, you can also pre-register if you want to ask any question to the guest. And so right now I'm going to send this thing. And students, all of you, please make sure that you ask right kind of question. That is very important. So, and then you mute yourself if you are in a noisy location. And so let's get things started. So I am going to accept you as soon as you guys join into the Zoom. I sent you the Zoom link, and hopefully we are going to get your students. Yeah, so our first students join. So I'm just trying to admit them as they join. And students, you can ask your question. Okay. Omkar, you can stop sharing so that we can see all the
Okay.
students. And then if you want to need to share, then you can do. Okay. Okay, so who has a question? You can. Okay, so today's question would be in English. Okay, so Rudra Pati, I am asking you to unmute. Please ask your question.
Hello, sir. I am Rudra Pati.
Hi, Rudra.
Hi, Rudra.
Yeah.
Nice to meet you.
So, sir, my question is the Milky Way a collision of two galaxies?
Uh, well, what scientists say is that there will be a point in the future where I believe the Milky Way and the nearest, the other galaxy, Andromeda, they might merge together in the future. I'm not sure if the Milky Way itself is a collision of two galaxies. Um, I haven't explored that area of astrophysics uh, in detail myself. But from what I vaguely remember, I think the Milky Way and the Andromeda galaxy, which are uh, two neighboring galaxies, there will be a point in the future when they fuse together.
Okay, sir. So, sir, my next question is: does the sun move around the Milky Way?
Yeah. So the entire solar system moves around the center of that spiral galaxy, the Milky Way, just like the Earth moves around the sun.
Okay, sir.
Okay. So next question is Sudipti. Sudipti, you can unmute. Sudipti.
Hi, sir. Good evening.
Good evening.
So, sir, my first question is Is science believes in gods?
So science deals with the natural world, and uh, a lot of the science that was invented early on uh, was done so by people who were pursuing questions that you might consider religious questions, right? For example, Galileo himself or Newton himself were deeply religious people, and when they were trying to look at the heavens, they were convinced that they were getting access to the way in which God has created the universe. That was their belief that time. So what science does is it tries to focus on explanations that don't appeal to supernatural phenomena, right? That doesn't mean supernatural phenomena does not exist, although, you know, over time, what we see is that more and more scientists tend to favor naturalistic explanations and also philosophically rule out the supernatural. But methodologically, science does not comment on whether or not there is a god or whether there are gods. It's the focus is on coming up with explanations that are naturalistic. That means um, they appeal only to other entities within nature. And that's the same with history also. When you study history in school, the idea is to explain the past by appealing as much as possible only to human factors, right? So a battle that might have been won by one tribe against another might have been attributed by that tribe to their god, that our god helped us and that's why we were able to conquer this other tribe. But from a historical standpoint, a historian will try to look at superior, perhaps superior battle tactics, or other kinds of human factors that might have played a role in the victory of that tribe. A historian will look at the beliefs of those people, that these people believed that their god helped them and that's why they won. So but a historian would describe those beliefs. A historian wouldn't say that because they believe those things and so those beliefs are true. So in both history and science, we try to describe nature by appealing to human factors or natural factors methodologically. uh, on top of that, if you know there are scientists and there are historians who might believe in some god or gods, but
Missions
that's a
also.
philosophical thing. It's not something that is part of the discipline of science and history methodologically.
So my second question is why the shape of observative is round. The India's big observative shape is round.
Yeah, so basically you need a roof. So there are two things, right? Many of the observatories have planetariums, and the planetarium shape has to be uh, similar to the shape of the night sky, right? People in ancient times thought that the sky was actually a hemispherical dome that envelops the earth. And so by having a roof with that same shape, when you're sitting under the roof inside a planetarium, they can project the stars and the night sky exactly the way they look to us from Earth. So that's as far as the planetarium part of the observatory is concerned. The telescope, right, these observatories are mainly for housing telescopes. The telescopes need a retractable roof so that they're not damaged by rain or snow or whatever. So you need a roof that can slide open. And so these curved roofs on top of observatories, they can actually open and allow the telescope to look outside whenever the scientists want to.
So my third question is
Yeah.
Okay, so Dipti, you
how
ask your question.
okay sir. Uh, how telescope is moving since 1990 by battery or something else?
Yeah, so there will be some kind of electrical power. I don't I'm not familiar with the details of the engineering for the Hubble Space Telescope, but they keep, you know, we have the International Space Station also, right? So they, there are astronauts that keep going to the space station. And so when there are repairs to be done to the Hubble Space Telescope or other kinds of things to be done, they do it periodically from time to time. So whenever the telescope is damaged, either because of battery failure or some other component going wrong, they have ways to, I mean, it's a lot of effort, but they have ways to reach there and fix the telescope.
Okay, great. So next, I will give chance to Avijit. Avijit, can you please unmute and you can ask your question?
Hello, sir.
Yeah.
Yeah.
I am Abhijit Sethi, and my question is, how can we know that there are other galaxies if we can't leave ours?
Yeah, that's a great question. Unfortunately, I won't be able to answer that question in short, but you know, Hubble himself played a role in the discovery of other galaxies. So till 100 years ago, uh, we didn't know about the existence of other galaxies, right? Just like we started out first thinking that the solar system is the entire universe, right? Maybe there are stars, but they are not that far from the solar system. And then the size of the universe expanded, and we started realizing that the universe is much bigger than we thought. But still, we thought the solar system is something unique. And then when later on, we found that the Milky Way galaxy itself has 100 billion stars, many of which might have conditions similar to our solar system. But then we still continue to think that this is the only galaxy until uh, about 100 years ago, when astronomers figured out that there was certain data, like Andromeda is something you can see from a telescope. There was some data about it which uh, could not be explained by using the physics of that time, right? Which assumed that uh, Andromeda is something that's very relatively close to us. Based on the calculations that they did, there's something known as Hubble's law, which describes how uh, the farther things appear to be from us, the faster they appear to be moving away from us. There's that rough relationship that they discovered, and based on that, they realized that Andromeda is actually much, much, much farther than we ever thought. So it's way outside our galaxy, and then based on other data, they figured out that it's a galaxy of its own. And in fact, there are many, many such galaxies, millions, maybe billions of such galaxies making up the universe. And now some physicists go in the direction of asking whether ours is the only universe. Maybe there are multiple universes.
Okay, thank you, Omkar. So next, I will ask to Sorosomya Das. Sora, you can ask your question. I ask you to unmute.
Hello, sir. I'm Swara.
Hi. Yeah,
So,
hi.
sir, my question is, there are facts that how did life come to our world, right? Only myths and complex chemical formulas. But where did the lives matter, come from? How can only the oxygen and hydrogen made, create life? That's my question.
Yeah, that's a great question. In fact, there is an entire field, that's an entire field of research, right, on the conditions that supposedly existed on the early Earth. So there are some scientists who think that life on Earth might have come from other planets, but many of them seem to think that conditions on the early Earth somehow led to the creation of the first self-replicating molecule, whether it was DNA or RNA. But it's not. It is a field of research, and I'm not an expert in that field. I just try to study the history of uh, some of these ideas. Um, but yeah, that's a valid question. One thing I just want to mention is, that the early Earth is not supposed to have oxygen. It was not an environment rich in oxygen, and so the conditions were what we call as anaerobic, where there was no oxygen. And so early life is supposed to have originated in the deep oceans, right, where the temperatures were suitable for complex organic molecules to form. Now, I don't think anyone has um, shown how life actually originated from those conditions. It's an assumption that scientists go with, and many times you find this in the history of science, that there are people who assume that something which cannot be explained today could be perhaps explained in the future if we assume and try to explore in that direction. So maybe we will never, maybe science will never figure out how life originated. Maybe it will. We don't know at this point. But
Uh,
it's a great question and an open field still of research.
okay,
The origin, yeah.
so my second question is, how much Milky Way is discovered?
How much? Sorry, what's your?
So
I didn't
I
get your
think
question.
she wants to say how much of the Milky Way we know.
Oh, it's a
For discovery.
very tiny, yeah, very tiny percent, because as you saw in that picture, we are located on one side of the Milky Way. So obviously we don't have a view of what is on the other side, because the stars that are close to us in the direction of the center, those stars are blocking the view from, from other stars. So you have to use, physical theories, astronomical theories, a lot of math to model how galaxies might form and be structured, as assuming. So it's all about coming up with mathematical models which make predictions, and the more you can validate some of those predictions, the more confidence you develop in those models. So the shape that
Okay.
you saw, the spiral shape, is what scientists have inferred from these mathematical models. Obviously, nobody has risen that high up to see what the shape is actually like. But there are other spiral galaxies that we see which have a
Okay.
similar.
Thank you, Swara. So I will ask
I have
next
a
question.
question. So
Swara,
please,
just wait. We'll get another chance. Don't worry. Okay. Smaronika Mahapatra, I am unmuting you. Smaronika, please ask your question.
Hello, sir. I'm
Hello.
Staranika. So my question is, which hemisphere has the best view of the Milky Way?
Uh, I'm not sure if you get a better view of the Milky Way from the southern hemisphere. I mean, most of the civilizations were uh, were born in the northern hemisphere. So the ancient descriptions of the Milky Way were mostly from the northern hemisphere. I'm not sure if the southern hemisphere has a better view. Uh, so in a sense, I don't know the answer to your question, if at all.
Oh,
If
okay.
there is even a difference. Have you heard of there being a difference?
No.
Yeah. So yeah, I'm not sure that there is a difference. There are some stars, obviously, that you can't see from the northern hemisphere, which you can see from the southern hemisphere. But uh,
My second question
mm,
is Andromeda part of the Milky Way?
no, it's a separate galaxy.
Then where can I find them in the sky?
You can consult a star map, uh, and so maybe in future sessions we could. So there is a software. If you can't see the night sky in your city,
I can share. So what is the software name? Yeah. So you can see my screen, guys.
yeah, Stellarium.
Okay. So you should look at this software if you have a PC, right? I think it work on a PC, right? Or does it work on Android?
I think it works on a PC. Yeah, I used to use it on a. It's STLLA.
Yeah. I think it's
STELLA, Stellarium.
yeah. I think
So
so. Okay. So this is the software that Omkar is saying.
yeah, this is a
So it,
planetarium software, right? So that means you can install it on your computer, and it will show you a view of the sky from your location. So you plug in your latitude and longitude, and it'll show you a view of the night sky at any time that you plug into the software, right? So if you want to see what the night sky looked like 5,000 years ago from a place in Orissa, you could plug in the coordinates and the dates accordingly. And there are ways to search, right? This software gives you a way to search for planets, stars, galaxies, and it will tell you their location in the night sky, which means when you go out, you'll be able to pinpoint the location or the direction in which Andromeda lies. But you would need a telescope to see it properly.
One question more.
Yeah, so I just want to say something here. So basically, you are going to see 6 lakh star. Okay, there's a default catalog there.
Okay.
Like 6 lakhs stars, and also as Omkar said, right, there are a lot of things. So either you can go to the Patani Samant Planetarium in Bhubaneswar, right? That's one way, and another way is plug this thing in. Maybe you can see a lot of things. And I strongly recommend, like whoever has interest in these kind of things, you should go and visit the planetarium in Bhubaneswar. That's a okay. So what's the next question?
Uh, yes, actually, how can we see the Milky Way if we are inside it?
Yeah, we can only get a side view. Even if we go to other planets in our solar system, we are still, the whole solar system is like a small speck. So basically, physicists and astronomers have to uh, build a model, right? The Milky Way is, or the picture that you saw, is a visual model of what they think it looks like based on the laws of physics,
Yes.
right? So they have inferred that based on you know a lot of mathematical analysis. These are mathematical models. So you nobody has directly gone to that location and seen the Milky Way is like that, but you do see other galaxies from far away. And so combining that data with the data that you have of nearby stars in the Milky Way, they come up with that model.
Yes,
Okay,
so
sir.
basically, clearly, whatever we showed you now on that Milky Way, that spiral stop, that is not a picture. That is based on some mathematical visualization, right? And this is maybe what's going to happen, but nobody knows, right? We cannot really, like, if you think that that is the,
Yes, nobody proper knows about that.
yeah, if you think that is a photo of the Milky Way, that's wrong. Okay, so that is a model
Yes.
visualization. Okay, thank you, Smaranika. So next
Okay,
I will
thank you,
ask.
sir. Nice to talk with you.
Okay. So thanks. Next is Rasmi Ranjan Mahapatra. I am unmuting you. Please ask your question. Rasmi, please
Hello,
ask your
sir.
question. Yes.
Myself, Prasmin Ranjan Mahapatra, and my question is, uh, does artificial lights harm for our health and also our body skin?
So the question
No,
is,
it's not.
okay.
Yeah, light pollution is obviously not directly harmful to physical health like air or water pollution is. But so this is my personal view. I think the problem with not being able to see the night sky. I grew up in Delhi, and even in the 1980s when I was growing up, with my friends, we used to try and see some of these constellations, and we would. I mean, the Delhi sky was bad even then, right, for observing the night sky. So uh, the real value, I think, of not having light pollution is that when you can see the night sky, you get connected to it. That is when you actually start learning science. There is a reason why astronomy is the first science that developed and not physics or chemistry or biology, geology. These are all very recent sciences, right? Physics, in fact, emerged out of astronomy, but chemistry and biology, geology, they developed only in the last few centuries. Why is it that astronomy started developing a few thousand years ago? Well, it is because the the simplest patterns in nature, the simplest examples of regular patterns in nature are in the night sky. So when you don't have light pollution, you are able to see those simple patterns, which you don't right now because of artificial lights. And when you see those simple patterns, you develop that curiosity to find out why those patterns exist. And then you try to come up with explanations for them. Ancient cultures had stories to explain them. But later on, as we'll see, when philosophy was invented, uh, philosophers started to think in some new ways, to try to think about the night sky in alternate ways, right? New ways. That led to uh, the development of geometry, for example. A lot of the geometry was developed in the context of observing these patterns in the night sky. We don't see perfect circular motion anywhere on Earth, right? You only see that in the night sky. And so science, mathematics, um, was invented through astronomy was the first science to be invented, right? And mathematics in association with astronomy, at least geometry. So I think when we have light pollution, the problem is that it prevents us from learning science the way we should, because we don't get access to that direct data. We don't see that direct data ourselves. What we instead learn about science is the laws of motion, and all the final products of science are presented in our textbooks. And we never perceive that sense of mystery. We never understand how science is actually hitting at our common sense. As I said, if you don't find science hitting at your common sense, there's something wrong in your understanding of science, right? So that's the reason why we are starting with astronomy, because we want to understand what exactly is science and how was it invented. And only the night sky provides you that entry point.
Okay, great. So thanks, Omkar. I think all of them has asked questions. So anybody wants to ask second question, please raise your hand. Omkar, how much time you have?
I have some minutes, yeah.
Some minutes, okay. So basically I'm going to this thing. So Sorosomya, I'm going to allow you to ask the question. Please unmute. Sora, unmute and ask your
Thank
question.
Okay, sir. So I hear that the moon is going far from Earth. So what is the real reason?
The real reason why, so the moon is, yeah, going a little far each time. So I think it boils down to how you model those laws, right? I mean, by definition, uh, when you look at motion in the solar
Yes,
system,
sir.
it's
Confused.
it's yeah, it's governed by the laws of gravitation, right? So when you have a body that's going in an elliptical orbit around another body, and um, uh, it's also controlled by other objects, right? I don't think the moon itself is, but in general, it's an n body simulation, as they call it, where if you want to figure out how a body moves in the solar system, you have to account for the gravitational forces from everything else in the solar system, not just the Earth, but also other objects. So, and I'm not sure if you've studied that in your school science, but the orbits of the planets can be like they're not obviously perfect circles. They're also not perfect ellipses. They are like one of the shapes that's mentioned is a perihelion, where it's an elliptical orbit which does not turn back on itself, right? So there will be some such complicated explanation for why uh, the moon is moving farther away, because when you model it as mathematically using the language of calculus, that's what you'll find. I'm not sure if there is an intuitive explanation for it.
Okay.
Right, because
okay, thank you.
finally, how did the moon? How did the moon form? Basically, there were these asteroids that collided with the early Earth, and pieces broke off, and then those pieces came together and formed a satellite of the Earth, which is the moon. And so since that time, yeah.
This was my second question, and actually, then The third question is, do Earth have dark matter?
No, dark matter is something that nobody has seen. So scientists just believe that there is something called dark matter because there are deviations from the known laws of physics that cannot be explained in any other way. Right?
Okay.
So dark matter, dark energy, these
Okay.
are
Thank you,
just
sir.
theoretical constructs to explain deviations from the laws of physics by postulating that there is matter that we can't detect. So
Okay. Thanks, sir.
nobody
Thank you,
knows.
Spera.
Yeah.
I will ask
Okay,
Rudra.
thank you.
Rudra has one more question. I'm unmuting Rudra, so you can ask question to Omkarji.
Sir, my another question is, are the plans of solar system aligned with the plan of galaxy?
The plane of the solar system, is it aligned with the plane of the galaxy? I think the plane of the galaxy would be, I mean, the solar system itself is a tiny speck, right? And the galaxy itself will have a huge width. So it's not really a plane. You can say it's a rough plane, but it's not going to be like they're completely different scales, right? So I'm not even sure if that question is well defined as to what the plane of the galaxy is, whether we can even define it to that accurate degree that we can compare it with the plane of the solar system.
Okay. So sir, is Milky Way is flat?
No, it's just a first approximation, right? It depends on what level of scale you go to. If you zoom out to a huge degree, then it might appear to be roughly flat, just like the Earth uh, around you appears to be flat. But you know that if you were a bacteria or a small insect, then even the flat road might not appear flat.
Okay,
So
sir.
yeah, so it depends on what scale you look at. Spiral galaxies, yeah, I mean, you can say they have an overall flat shape, but obviously the closer you zoom in, it won't appear as flat. You may not even see a perfect boundary to the galaxy because there'll be different star densities at different heights above the plane.
Okay, sir. Thank you, sir.
Okay, thank you. So anybody else has any question? I just want to see Abhijit. So whoever asks question, you can basically you can lower your hand, please, so that way I will know who has asked question. So that way I'll go. So basically, Abhijit has a question then. Abhijit, I'm unmuting you.
Okay.
Yeah, Abhijit, please ask a question.
Sir, my other question is, how can we make a star map?
How can we make
How
a
can
star
we
map?
Yes.
Star map. Okay,
So
Abhijit,
star maps have already been made by uh, astronomers. I mean, they've been made since ancient times, but modern star maps are available in books, and you can probably get them even online. But as I said, Stellarium is um, a great software because it gives you a 3D view of the sky. A star map will be, by definition, a 2D map. There are also some simple Android apps on your phone. I think there is one called
yeah, there is some Google
Sky
Sky
Map.
or something. Yeah,
Sky
Google
Map,
Sky.
yeah. So if you want a crude version of um, like a star map, you can download the Sky Map app on your phone and
Yeah,
point
you
it
can. Yeah, yeah. So basically
point it
that is
at the
that.
sky.
Yeah. So what you can do today, task is basically get the Sky Map app installed on your Android phone, and then basically show your map, show the phone to the open sky, so you can see in which direction is your the planets are, where is Jupiter, where is Saturn, and everything. It will show you, if I move to this way, and I can see, what is the in that direction, what are the stars are there. So you can see, a lot of times, your astronomers tell you the bhavishyavani, right, like future thing, right? You can also predict depending on this thing, right? Okay, I think we have all questions probably answered. So what we could
Sir,
do?
I have
Okay,
a other
another.
question.
Okay,
Mhm.
fine, fine. Go ahead.
Okay.
Sir,
Sir, what
I
is the
also have another question.
Okay, okay, fine. Okay. Okay.
Sir, what is the connection between the galaxy and the black hole?
Well, many galaxies have a massive black hole near the center, because after all, it's gravitation that is making everything move around, right? So near the center of the galaxy, there is often a massive black hole because that's where all the mass collects uh, by the force of gravity. So uh, that is the connection, I guess. I'm not, by the way, a professional astronomer or a professional astrophysicist. I have, you can say, I have an amateur interest in the history of ideas, and so astronomy is one of those things that I have a special interest in the history of because, as I said, it's the earliest science. So you might get a more detailed answer from somebody who's a professional astronomer or astrophysicist. But my crude answer is the connection is that the center of the galaxy will many times have a supermassive black hole because that's where the mass collects. And as you know, a black hole has so much mass and so little volume that even light can't escape from it. So that's that's the connection.
Okay, so Dipti, what is your question?
Sir, it's me actually.
Okay, who? Swara, okay, ask your question.
So, sir, I hear this in a show that some scientists are trying to send an object to space to see what exactly happened after Big Bang. Then, in other words, it's like to travel to the past, right? So, is it possible?
So whenever you try to infer anything about the past, the assumption is that the events from the past triggered some causal, some things to happen whose evidence you can still detect today. So I don't know the details of what you're referring to, but in principle, when we try to reconstruct the uh, events of the early universe, we do so by using a logic that goes something like this: if event A happened, then it would have caused event B to happen. And if event B happened, then we should be able to detect evidence of event B today. And if we are able to detect the evidence for that, then that confirms that event A happened. But if somebody says, no, it was not event A that happened, it was some event A complement which happened in the early universe, well, then what are the consequences of that other that other story, right? You reconstruct what are the other predictions that should follow, and then you look out for evidence of those other um, predictions, and depending on what you actually observe, you can differentiate between those early, those alternate hypotheses for those early events. So that's what they do when they try to go out and observe um, cosmic background radiation or other remnants of um, the early universe.
Okay,
Okay,
I think
thank.
it's already 10:30, 9 o'clock here in US. So I think we should conclude today's session. Yeah, thanks for a lot of your question. So thanks Omkar. It was a kind of a dream for me to bring you to this forum, to the platform, and then to get students in Odisha to get interest in science. And definitely we are going to do this thing. So this is a Saturday program, students. So Saturday we are continue to do is in English, and Sunday as usual. Tomorrow there is a 9 p.m. class, and tomorrow we are going to Berlin. And tomorrow the topic would be Berlin Wall, and we'll see how we need to break the wall and make a bridge, right? So that is our topic for tomorrow. Tomorrow is going to be very much into social and history and all this thing. So do join us, and then have a lot of questions, and then again, see you tomorrow at 9 p.m. and India time. Okay, thanks Omkar, thanks all of you students. Goodbye.